Hi everyone, continuing chemical equilibrium, law of mass action. It was proposed by Goldberg and Weig. According to law of mass action, at any instant, rate of a chemical reaction is directly proportional to product of active masses of reactant at that instant. Definition already given in last video. Now example, consider a reversible consider consider a reversible consider a reversible reaction small a moles of A plus small b moles of B gives rise to small c moles of C and small d moles of D. And also consider reaction is present at equilibrium state. Now according to law of mass action, according to law of mass action, rate of forward reaction RF, rate of forward reaction directly proportional to active mass of A moles of A and active mass of B, reactant B, number of moles raised to its power. Okay, by removing proportionality we get constant, rate constant small kf, rate constant for forward reaction, active mass of A raised to power A moles, active mass of B raised to power B moles. In the similar way, rate of this backward reaction is directly proportional to product of active mass of reactant. What are reactants for backward reaction? For backward reaction, C and D are reactant. For backward reaction, C and D are reactant. So, rate of backward reaction directly proportional to its reactant C and D, that is active mass of C into active mass of D raised to their power stoichiometric coefficient. What are stoichiometric coefficients of products here? C and D. Now rate of backward reaction is equals to, by removing proportionality we get constant, that is rate constant in backward reaction Kb, active mass of C raised to power C into active mass of D raised to power D. But at equilibrium state, rate of forward reaction is equals to rate of backward reaction. At equilibrium state, rate of forward reaction is equals to rate of backward reaction. What does it mean? It means rate of forward reaction is equals to rate of backward reaction. That means Kf, what is RF? Kf into active mass of A power A into active mass of B power B is equal to what is RB? RB is Kb into active mass of C power C into active mass of D power D. Okay, now this equation, we can write this equation, Kf by Kb is equals to what? So this comes to denominator and this term comes to denominator for the RHS side. Then it becomes Kf by Kb is equal to what? Active mass of C power C into active mass of D power D by active mass of A power A into active mass of B power B. Since equilibrium constant capital K is equal to rate constant for forward reaction by rate constant for backward reaction, equilibrium constant K capital K is equal to Kf by Kb. So we can write like this: equilibrium constant capital K is equal to active mass of C power C into active mass of D power D by active mass of A power A into active mass of B power B. This is equilibrium constant in terms of active masses. So what is active mass? In last video, as we discussed, active mass is, what is active mass? Active mass is old term. So what is active mass? For gases, active mass is, for gases, active mass is molar concentration. Active mass is molar concentration or partial pressures. In some books only partial pressures given, but active mass is molar concentration or partial pressures. For gases, active mass is molar concentration or partial pressure. But for liquids, active mass is molar concentration only. Molar concentration only. So equilibrium constant K, if you see equilibrium constant capital K in terms of molar concentration. Equilibrium constant in terms of molar concentration. Kc is equals to, for above reaction, instead of active mass of A, B, C, D. So now active mass of C power C become molar concentration of C power C. Active mass of D become molar concentration of D power D, likewise. So Kc is equal to what? Kc is equal to molar concentration of C power C into molar concentration of D power D by molar concentration of A power A into molar concentration of B power B. In the similar way, equilibrium constant in terms of partial pressures. Equilibrium constant in terms of partial pressure, denoted with Kp. Kp is equal to, now instead of molar concentration we use partial pressure. That means partial pressure of C power C into partial pressure of D power D by partial pressure of A power A into partial pressure of B power B. So what are these? This is equilibrium constant in terms of molar concentration, and this is equilibrium constant in terms of partial pressures. Okay, if you see relation between Kp and Kc, relation between, this is very important, relation between Kp and Kc, relation between Kp and Kc, equilibrium constant in terms of molar concentration, equilibrium constant in terms of partial pressure. Now consider a reaction, a small a moles of A plus small b moles of B gives rise to reversible reaction present at equilibrium state, C moles of C, D moles of D. This is a reversible reaction present at equilibrium state. Now if all these are gases, reactant A, capital B are gases, products capital C, capital D are gases. That means all are gases. Then what is Kp for this reaction? Kp for this reaction is product of partial pressures of products. What are partial pressures of product? Partial pressure of C into partial pressure of D raised to their powers stoichiometric coefficient. What are stoichiometric coefficients here? C small d by partial pressure of A power A into partial pressure of B power B. Consider it as equation 1. Then what is the equilibrium constant in terms of molar concentration for above reaction? Molar concentration of C power C into molar concentration of D power D by molar concentration of A power A into molar concentration of B power B. Okay, consider it as equation 2. Now to establish relation between them, you need to substitute partial pressures in Kc equation or molar concentrations in Kp equation. So do one thing. For ideal gases, what is ideal gas equation? PV is equal to, ideal gases follow this condition, PV is equal to nRT. Then what is P? P is equals to N by V into RT. Since concentration is the ratio between number of moles to volume of the solution, we can also write like this: pressure is equals to concentration into RT. What is equilibrium equilibrium symbol for concentration, molar concentration? Square bracket into RT. So here remember, square bracket is what? Molar concentration. Concentration expressed in molar concentration. Concentration expressed in molarity. Okay. Now if it is partial pressure of A power A, what we can write? Partial pressure of A power A become molar concentration of A power A into RT power RT whole power A. Consider it as equation 1. In the similar way, partial pressure of B power B become molar concentration of B power B into RT whole power B. Consider it as 2. Partial pressure of, in the similar way, partial pressure of C power C become molar concentration of C power C into RT power C. It is 3. Then partial pressure of D power D become molar concentration of D power D into RT power D. It is equation 4. Now substitute equations 1, 2, 3 and 4 in equation 1. Equation 1 లో sub equations 1 2 3 4 substitute చేయండి. Then sub equation 1 2 3 4 have to substitute in this one. Now what you get, Kp is equal to instead of partial pressure of C power C, what you can write, molar concentration of C power C into molar concentration of into RT power RT whole power C. Instead of partial pressure of D power D, what you can write, molar concentration of D power D into RT whole power D by, instead of partial pressure of A power A, what you can write, this term. That is what, partial pressure of A power A is equal to molar concentration of A power A into RT power A. Instead of partial pressure of B power B, what you can write, molar concentration of B power B into RT power B. So write molar concentration of B power B into RT power B. Okay, then Kp is equals to separate concentration terms, C power C into D power D by molar concentration of A power A into molar concentration of B power B. So what are remain in numerator, RT power C into RT power D by RT power A into RT power B. Okay, then Kp is equals to, instead of this molar concentration of C power C into D power D, molar concentration of A power A into B power B, what you can write, Kc. So all term is same. Okay, instead of molar concentration of C power C into D power D by molar concentration of A power A into B power B, what you can write, Kc into RT power C into RT power D become RT power C plus D by RT power A into RT power B become RT power A plus B. Bases, if bases are same, power should be added. Then Kp is equal to what, Kc into, if RT power A plus B present in numerator comes to RT power comes to numerator, denominator term comes to numerator, then what you can write, RT power C plus D and RT power minus A plus B. Then Kp is equals to what, Kc into, then RT, bases same, so powers, add powers, C plus D minus A plus B, and Kp is equal to what, Kc into RT power. What are CD? If you see CD are what? CD are gaseous moles, number of moles of gaseous product, and AB are what? Number of moles of gaseous reactant. So what are CD? Number of moles of gaseous product minus number of moles of gaseous reactants. Then Kp is equal to what, Kc into RT power delta N. So this is relation between Kp and Kc. So Now what is delta N? Delta N is change in number of moles of gases. N number of moles of gaseous product minus number of moles of gaseous reactant, all are gases. Okay, right. NP is number of moles of gaseous product, NR is number of moles of gaseous reactant. NP number of moles of gaseous products, number of moles of gaseous products, and NR is what? Number of moles of gaseous reactants, number of moles of gaseous reactants. Okay, so Kp Kc relation depends on what? Delta N. Kp Kc relation depends on what? Delta N. This is very important equation. This is very important equation. So always Kp Kc relation depends on, at given temperature T is constant, R is universal gas constant. So Kp Kc relation depends on what? Kp Kc relation depends on delta N value. If delta N is different, Kp Kc relation is also different. See, example N2 plus 3H2 gives rise to 2NH3. It is gaseous reaction. Then what is the Kp Kc relation for this? So for gaseous reaction we can write Kp and Kc also. What is Kp Kc relation for this reaction? Kp is equal to what? Kc into RT power. What is the delta N for this reaction? For any reaction, delta N is the number of moles of gaseous product minus number of moles of gaseous reactant. How many gaseous products here? Only 2. So how many gaseous reactants here? Number of gaseous reactants here are 1 plus. So if there is nothing, that is what? 1 mole, and this is 3 mole. 1 plus 3, that become what? 1 plus 3 moles. That means what? 2 minus 4, that is equal to minus 2. Therefore Kp is equal to what? Kc into RT power minus 2. Remember, if it is minus value in the sense what? Np, when will we get delta N is negative? If condition, when will we get delta N negative? In case when Np less than Nr, number of moles of gaseous reactants greater than number of moles of gaseous product. That means whenever Np is less, remember in this way, just for remember, if Np is less, then remember Kp is less than Kc. So just to remember, if Np is less, then Kp is less. You need to remember in this way. Okay, next, if example 2, it is example 1. Example 2, I am taking example 2. What is example 2? If H2 plus I2 gives rise to 2HI is example. Here H2 is gas, I2 gas, and 2HI gas. If it is the reaction given, then Kp Kc relation become Kp is equal to what? Kc into RT power. So what is delta N? Np minus Nr. What is Np? Np is equal to 2, Nr is equal to, that means delta N is equal to what? 0. So that means delta N is equal to 0 means RT power delta N kabatti RT power 0. Something power 0 is equal to 1. Kp is equal to what? Kc into 1, that means Kp is equal to Kc. That means whenever Np is equal to Nr, then Kp is equal to Kc. If Np greater than Nr, then what become Kp greater than Kc avutundi. So see that example also. Example 3. So in this example, Kp greater than Kc condition. So that means number of moles of gaseous product PCl5 plus reactants products greater than reactant. So PCl5 gas gives PCl3 and Cl2. I mean decomposition of phosphorus pentachloride gas. Then here delta N is equal to Np minus Nr. We know this formula. Np is equal to, so 1 plus 1, 2. Nr is equal to what? Only 1. So 1, that is delta N is equal to positive. Okay, and remember formula Np minus Nr kada. Right, here Np greater than Nr condition. Np greater than Nr condition. Then what become? Kp is equal to what? Kc into RT power 1 kada. So R is universal gas constant, that is some positive value. Absolute temperature is also always positive. Of course, normal temperature small t may be negative, but absolute temperature is always positive. Universal gas constant is always positive. So some positive term power 1. That means Kp greater than Kc. Kp greater than Kc. So to understand, clue. This is just a clue. There is no any scientific reason. Okay. Np, if Np greater than Nr, just in competitive to identify easily, if Np greater than Nr, then what do you say? Kp greater than Kc. If Np less than Nr, by looking at equation you can write Kp Kc relation. Kp less than Kc. If Np is equal to Nr, then what you can say? Kp is equal to what? Kc. Kp is equal to Kc. So this is important. This is short way to write relation between Kp and Kc. So by looking at this relation, if Np are greater in the equation or Nr is greater in the equation, so you can write whether Kp is greater or Kc is greater. Hope you understand. Okay. Now units also depends on delta N value. Units also depends on delta N value. Now it will be, what are units of Kp? Units of Kp is equals to partial pressure units atmosphere power delta N. Units of Kc are units of Kp moles per liter power delta N. So liter denoted with L, capital L, liter denoted with capital L, moles per liter power delta N. That means units also depends on delta N. Kp Kc relation depends on delta N, and units of Kp, units of Kc also depends on delta N. Okay, if you want to see some previous question, I mean question asked in 2024 on Kp Kc relation పైన 2024లో అడిగిన క్వశ్చన్స్. యాక్చువల్లీ ఒక ఈ వీడియోలోనే మొత్తం చెప్పాలి అంటే మేబీ see this question is for the reaction viewers, you can follow, you can forward క్వశ్చన్ కంప్లీట్ అయ్యేంత వరకు ఫార్వర్డ్ చేయొచ్చు. నేను రాస్తాను మొత్తం క్వశ్చన్ని. ఫర్ ద రియాక్షన్ వాట్ ఈజ్ రియాక్షన్? N2O4 gas gives rise to 2NO2 gas. For this reaction, Kp value given, that is 0.492 atmosphere at 300 Kelvin. Kc for the reaction. Kc for the reaction at same temperature. Is dash into 10 power minus 2. వ్యూవర్స్కి ఒక పాయింట్ నోటీస్లోకి తీసుకొద్దాం అనుకుంటున్నాను. సో ఇంకొక 1 or 2 వీడియోస్ తర్వాత మార్కర్ బోర్డు పైన నా క్లాసెస్ ఉంటాయి. సో అప్పటి వరకు ఒక 1 or 2 వీడియోస్ ఇట్లా కంటిన్యూ చేస్తాను స్క్రీనింగ్ మీద. ఓకే, రైట్. సో ఆఫ్టర్ 1 or 2 క్లాసెస్ అవర్ క్లాసెస్ విల్ బీ ఆన్ మార్కర్ బోర్డ్. క్లాస్ రూమ్ ఫీలింగ్ ఉండేటట్టుగా క్లారిటీగా వీడియో చేయడానికి ట్రై చేస్తాను. ఓకే, రైట్. దిస్ క్వశ్చన్ ఆస్క్డ్ ఇన్ January 29th, shift 1, January 29, 2024 question. Okay, how to solve this? Very simple. Kp given, asked to calculate Kc. Then solution. What is relation between Kp and Kc? Kp is equal to Kc into RT power delta n. So for the reaction given in the question, what is delta n? Delta n formula Np minus Nr. Number of moles of gaseous product minus number of moles of gaseous reactant. How many gaseous product? 2. How many gaseous reactant? 1. Gaseous reactant is 1. So delta n is equal to what? 1. So therefore Kp is equal Kc into Kp is equal to Kc into RT power 1. That means Kp is equal to what? Kc into what is Kc? Kc you need to calculate. So Kc is equal Kp by what is RT? Kp by RT kada, right? RT power 1 means RT. So Kc is equal, what is the Kp value given in question? Kp value is 0.492 atmosphere by what is R value? R value you need to take in atmosphere. What is R value? 0.0821 liter atmosphere per Kelvin per mole. And what is the temperature value? 300 Kelvin. So now Kelvin get cancel. Kelvin inverse get cancel. Atmosphere numerator denominator get cancel. Then what is Kc? Kc is equal 0.492 by if you multiply 0.0821 with 300, it become 8.21 into 3. So 3 2s are 6, 3 8s are 24. So it become 8.21 into 24.63. What are units remain? Liter mole inverse. So Kc is equal to what? Kc is equal, if you want to simplify it, you can also write like this. 0.492 become 49.2 into 10 power minus 2. And liter mole inverse in numerator become mole. Liter in numerator become liter inverse by 24.6 కదా. Then Kc is equal to what? Almost 2 times is become 2 into 10 power minus 2 mole per liter. Then Kc is equal to what? X into 10 power minus 2 mole per liter. Instead of x, what is our answer? Just see once what is question. X into 10 power minus 2. What is x? X is dash into 10 power minus 2. Question లో not x, dash into 10 power minus 2 అన్నాడు. సో వాట్ ఈజ్ డాష్ అంటే ఏం చెప్పొచ్చు మనం? సో డాష్లో 2 ఉంటుంది. ఆన్సర్ ఈజ్ 2. హోప్ యూ అండర్స్టాండ్. రిమైనింగ్ previous questions asked in 2024 will be discussed in next video. Thank you for watching.